What's up, students? It's your third lesson. It's called Midpoints and Bisectors, and our objective for today is for you to understand the definition of midpoint, bisector, and congruent, and you're able to apply these concepts to solve problems involving the length of line segments. Pretty cool, don't you think? I do. Let's start with some definitions, though. First thing, congruent. What does congruent mean? It means when two things are the same size, length, and shape. All right? Pretty much exactly the same. So for example, if I had a little line like this, all right, and it was 5 inches, and I had another little line that was exactly the same and 5 inches, these two would be congruent, right? They're the same size, length, and shape. I mean, my handwriting kind of sucks, so maybe not exactly, but you get the point. Two things that would not be congruent. Let's say I had a really big line, right, that was 10 inches, and then I had a really small one that was like 2. All right? So these would be not congruent. Now, to bisect is to cut in half. Okay? When you bisect something, is to cut in half. All right? Or two equal parts. Okay? Two equal parts. So an example of that, if I had, let's say, a cookie, and I bisected it, that means I just cut it into two equal parts. So this is half, right? I got half over here, and I got half the cookie over here. Now, something that wouldn't be bisected, let's say I had this piece of spaghetti, and I cut it over here. Okay? This is my spaghetti, and I cut it over, yeah. This doesn't cut into two equal halves, so that is not bisected. All right, that's my piece of spaghetti. So congruent segments. Let's just go. This is what we do in geometry. We have to learn how to kind of mark things, and I'll explain that more right now. Oh, dots on this. Now, two segments are congruent. When two segments are congruent, we mark. Okay, we mark that they are congruent or of equal length. Okay. With segment markings as shown below. So if two things are congruent, we just put these little scratch marks like this to say they're congruent. So since this has 2 and this has 2, I would say that AB is congruent to BC because the AB has these 2 marks and BC has those 2 marks. So these are congruent. Now if you look at this, they have the marks here. Oh, let me put these points in. They have the marks here, but they're not congruent, right? So this mark is not the same as this. This has 1, this has 2. So these aren't congruent. And if you look at it, this one, this segment right here is much smaller than this one. So they're not congruent pieces. So here we're going to start writing congruent statements. And congruent statements are basically when you just say when two things are of equal size or shape. So I'm going to keep putting the points. So in this example, I know that ST and UV are congruent because they have these marks here. So the statement would be this: ST is congruent, which is just an equal sign with this little squiggle right here, to UV. All right? That tells me that they're the same length. ST is the same length as UV. That's what this tells me. I'm just going to put a little thing in there so we know this means same length. Okay? Now in this one, we actually know the lengths. We know that BC and AD are the same length. So we know they're congruent. So we're going to put little marks here. Let's mark them, okay? We know BC is congruent to AD, and we put the marks. We also knew BA is congruent to CD. So we're going to put marks here. Now we're not going to just put 1 now. We're going to actually put 2. Because if we only used 1, that would say that this is congruent to this, which it's not. So now we know that BC, all right, oh, let's put this in blue. BC is congruent to AD, all right? BC, which is 5 inches, is congruent to AD, and BA is congruent to CD, and that's over here, right? BA is congruent to CD. They're both the same length. Now we're going to kind of go the opposite direction now. We're going to mark this figure using the congruent statement. So we have the congruent statement now. We're going to mark this knowing that. Well, we know AB, which is here, okay, this part right here, we know AB is congruent to BC, which is over here. All right? So since I know AB is congruent to BC, we're going to put a line here. AB is congruent to BC. So I know the same length. I also know that AD is congruent to DC. So AD, which is up here, is congruent to DC, which is over here. So AD is congruent to DC. And I just put these two markings now because I know these two are congruent. And that's it. So let's move on to a midpoint. What is it? It's exactly what it sounds like. So it just means the middle point. Now, the formal definition is a midpoint is a point on a line that divides a line into two congruent segments, okay? And congruent, once again, means same length, right? So two segments of the same length. Let's look at a piece of wood, all right? Let's say B was our midpoint, right? It's right in the middle. And I knew that AB, this part of the wood, was 10 feet long, all right? If B is right in the middle, how long is this part of the wood? It's also 10 feet, right? Because it's right in the middle. 10 feet this way, 10 feet this way. So we would say that they're congruent, and I'd draw like those congruent lines through it. Well, same conclusion can be reached here. If we know that B is the midpoint of AC, right, then I know that AB, this part of the segment right here, is congruent to BC, right? These two are going to be the same length. And the way we would write that is, as you see right here, AB is congruent to BC. Remember, this right here just means the same length as, all right? So instead of saying the same length, I just say congruent. Oh. So that was a little mistake. Let's say point B is the midpoint of AC, all right? If AB is 16, find BC. Well, we know this is the midpoint, so what do we know? We know that AB, this line segment right over here, is congruent to BC, right? These are going to be the same exact length. So what we're going to do now is, after we've done this, we've drawn it already, we're going to label the length of each segment. So we know AB is 16, so let's write that down here, okay? The next thing we do is going to write a congruent statement. And the congruent statement is this. We know AB, all right, line segment AB is congruent to line segment BC. That's this guy right here. We substitute the known values. So if I know that AB is 16, I'm just going to write that here. And we know 16 is equal to the length of BC. And that is how you solve this guy. So the length of BC, line segment BC, is just 16. Because if this is 16, then we know this has to be 16. Because B is the midpoint, cut it in half. You got it. Next part. If D is the midpoint of EF, and we know that ED equals 5x and DF equals 10, we want to find the length, the value of x. Well, the first thing to do is once again draw it, okay? It's not drawn for us this time, so let's draw it. So we have this, all right? And we have a midpoint. So right in the middle right here, this is D. And that is the midpoint of E and F. All right? We know ED is 5x, and we know DF is equal to 10. And also, we know that since D is the midpoint, ED is congruent to EF, and so we write those marks in. So now that we've labeled the length of each segment, we're going to write our congruent statement, all right? And that is that ED, this line segment right here, ED, is congruent to this line segment, DF. These two are the same length. To solve this, now we're just going to put in the known values. So we know that ED is equal to 5x, and we know DF is equal to 10. And now we have an equation. Now if you could solve this, go ahead, solve it yourself. But if you don't know how to, come watch as I solve for x. So what we're going to do is what we did last lesson. You draw a line down the middle, okay? Line over here. And this is the side with the variables, and this is the constants. Remember, constants are numbers. To solve for x, we're going to have to move all the numbers over to the side for numbers. To do that, we need the opposite operation. To move a number to the opposite side of this line, we need the opposite operation. So this is 5 times x. To solve for x, we're going to have to divide both sides by 5, because division is the opposite of multiplication. When I do that, these 5's cancel out, and I get x is equal to 10 divided by 5, which is 2. And that is how it's done. X is equal to 2. And does that make sense? Well, 5 times 2 equals 10, and this is 10, and they're the same. So, yup, we did it. Moving on to segment bisectors. What are they? What do they do? A segment bisector cuts a line segment into 2 congruent parts and passes through the midpoint. All right, now it might be easier just to look at it. So EF right here would be considered the segment bisector if it cut it in half. Well, let's see. If EF is the bisector of AC, so this line bisects AC. Remember, bisect means cut into 2 equal parts. What can we conclude? Well, since it cut AC into 2 equal parts, we know that AB, this segment right here, is congruent to BC, this segment here. All right? And we marked it, and now we just write a congruent statement. So we know that AB is congruent to BC. These are going to be the same length. So if this was 15, we know this is also 15. All right. 2. If DB is the bisector of AC, so this is DB. You know what? I want to try this highlighter function. Ooh. So if DB is the bisector of AC, so DB is the bisector of AC, what can we conclude? Well, we know when we bisect something, it cuts it in half. All right? So what we know is that DB bisects or cuts in half AC. So we know AB is congruent to BC, right? DB cut in half, those are 2 equal to each other. So to write our congruent statement, all we have to say is that, let's get out of this mode. Oh, nope, I want to go to pen. We know that AB is congruent to BC. Nice. Now finally, if MR equals 10 and RO equals 10, then what can we conclude? Well, there's a few things we conclude. One, we know that MR is congruent to RO, right? They're the same length. So that's an easy one. So we'll say that MR is congruent to RO. They're the same length. That's how we say that. Now here's the harder part. We see that R is in the middle here, so we also know that R must be the midpoint. Is the midpoint, right? Because it's in the middle. R is the midpoint. And finally, since this line PN passes through R, which is the midpoint, we know that line segment PN, all right, let me write it like that, is the bisector of MO. All right, so that's the conclusions you could reach there. One, we know that these are congruent because of the same length. R therefore must be the midpoint. And then PN must be the segment bisector because it passes through the midpoint, like our definition says. All right, guys, that's it for this lesson. Hopefully you know something about congruence. My only tip to you today is, remember, whenever you go home, make sure you have a checklist of things you should do. That always helps you stay organized. On top of that, don't eat too many cookies because that would make you gain weight. Which is okay if that's what you're into, but maybe some people aren't. You know what? I'm just gonna go. I'm just gonna go. Have a good day.